Hi, this is Wyatt Wilcox, and today I'll be talking about remote sensing of permafrost near Fairbanks, Alaska. So according to NASA, permafrost is ground that remains perennially frozen, and permafrost melt has been damaging to both Alaska's ecosystem and infrastructure. And we can observe permafrost melt by using remote sensing methods, and so I wanted to identify areas where permafrost melt is occurring and analyze permafrost melt from 2013 to 2019. So my first piece of literature was by Rudy et al., and they basically said that permafrost melt can be found by the amount of soil displacement in the study area, and this oftentimes takes the form of thermokarsts, which are pond to lake sized depressions in the ground that become filled with water. My second piece of literature is from Atkinson and Treats. This is one of the most important pieces of literature in permafrost remote sensing, and they basically said that vegetation covered in permafrost areas could be described in three classes of vegetation. My third paper is from Schaefer et al., and basically they said that you can monitor the thaw depth of soil in permafrost regions, and also they said that soil moisture absorption amounts actually had a correlation to the amount of permafrost. My study area is Landsat 8, path number 68 near Fairbanks, Alaska. So my first map was the unsupervised classification, and I have two versions from 2013 and then another from 2019. And basically I used the isocluster unsupervised classification method to do this. And I wanted to find frozen water, liquid water, and three classes of vegetation for both the 2013 and 2019 dates. And I found that with the three classes of vegetation, it supports the findings of Atkinson and Treats. So in my first one, I have June 27th, 2013, and then roughly 5 years later in 2019. And you can see the three classes of vegetation going along the valley on the right-hand side, and all the magenta areas are the rivers flowing down the mountain range. So I used the standard unsupervised classification method, so I composited and sharpened the bands, created an ISO cluster, and then I grouped and identified the different classes. My supervised classifications are in the same Landsat image but a different spot. This is about 28 miles to the east of Fairbanks, Alaska, and basically I was trying to focus on finding thermokarsts for my supervised classification. And I was able to, in 2013, find 18 thermokarsts using the object-based image analysis. And in 2019, I was able to find 35 thermokarsts. And there on the bottom is the true color image of the study area. So on the top is my 2013 supervised classification. I have the 2019 one on the bottom. And you can see there's a lot less thermokarsts in the 2013 one. So with my supervised classification, I basically segmented the Landsat images, and then I grouped them into the classes and basically told which segments were which class. And then I did the object-based image analysis using the support vector machine method. So my third map is the visible atmospherically resistant index, or the VARI, and basically it's similar to an NDVI, but it takes out the effects of the atmosphere using the red, green, and blue bands. And according to the Atkinson and Treats paper, the vegetation cover is tied to the growing conditions that exist over permafrost covered landscapes. And for my third map, I used an orthophoto that's about 79 miles southwest of Fairbanks in the city of Healy, Alaska. And basically the orthophoto was done in the winter, so I wanted to find out what the vegetation indices would be like in the frosted conditions of the winter, and see if that was similar to the way that the thaw season looked. And I found that all of the areas with no moisture in the VARI image were similar to the areas that had moisture in the thaw season. So I think that has something to do with the correlation between the snow melt and the permafrost melt below the surface. So here's the VARI map, and basically the red, orange, and yellow areas are the vegetated areas, and a lot of those are evergreen forest. But there's some pieces of farmland that were also still vegetated in the winter. But the frozen patterns in the blue there really resemble the vegetation strata from the Atkinson and Treats paper. So the methods I use for that, it's basically green minus red divided by green plus red minus blue. And I just extracted the 3 bands and used them for the raster calculator to find the vegetation indices. So my fourth and final map is the NDMI, and basically with this one I'm looking at vegetation moisture, because in the Schaefer et al. Paper it said that the vegetation and soil moisture was an indicator of permafrost melt, hence the ice below the surface melts and then more vegetation grows. So I use the NDMI equation to calculate this in the same area as my supervised classification area. And basically with the supervised classification I was trying to find just the amount of thermokarst that existed, but with the NDMI I was basically trying to find the soil moisture around the thermokarst and see if there was any relationship to the melted ice moisture coming up through the ground in the thermokarst zone. So I found that there was a bit of a correlation there. You'll see that all of the areas with the thermokarst in the image are surrounded by areas of like medium to high moisture, and so I believe that this is a way that you can correlate thermokarst and soil moisture here with the permafrost melt. So with the NDMI, it's basically the same method as the NDVI, but you're looking at the bands 5 and 6, and you just use those with the raster calculator in order to run the band equation there. So what went well? Basically, the unsupervised classification distinguished the 3 vegetation classes in the Atkinson and Treats paper. The supervised classification showed an increase in thermokarst, which indicates the melted permafrost. The VARI vegetation index showed the strata between soil and moisture amounts in the same way that the vegetation patterns were shown in the melting season. And also the NDMI soil moisture patterns correlated with the formation of thermokarst in the supervised classification study area. So what didn't go as well? Basically Alaska has a lack of orthophoto production compared to the continental US. The NAEP program doesn't go into Alaska, and so it was pretty tough to find orthophotos that were relevant to the study area. The Alaska DNR actually has an orthophoto program, but that was published as a web mapping service, so you're not able to do classification or any type of analysis in ArcGIS using the web mapping service. But in the future this will improve, because since 2015 there's been an initiative to increase the amount of Alaskan geospatial data. And in the future for research, I think that Alaska could use a more in-depth study of the formation of thermokarst and the way that it relates to permafrost melting. So here are my references, and thank you very much.